Now in this video I'm going to compare and contrast some of the integrals that we worked with in the previous video with ones that are very similar to them but yet a little bit different. So the integral that you see here is the one that we solved in the previous video. Now I'm going to change that. And if you look at the two integrals, we really haven't done a whole lot. You can say, because in the first one, that 2 is a constant multiple, it could really be factored out. And so you could say that the first integral is really 2 times the second integral, or the second integral is 1/2 of the first integral. So we could kind of solve it simply in that way. But let's just see how we would solve this second integral using U substitution. And I'm just going to bring down the answer from the previous video for the first one, and that was 1/5 x squared plus 1 quantity to the 5th power plus c. And if the second one is half of that, then I guess it should be 1/10 of x squared plus 1 to the 5th plus c. So let's see if we do the U substitution what we'll get there. We're going to let u be the inside function again, which is x squared plus 1. Now in this case the derivative of the inside function is 2x, which is not an exact match for the x that's on the outside, but it's a constant multiple of that. So as long as it's a constant multiple, we're going to be fine. So we take u equals x squared plus 1 and find its derivative. And then we solve for du, and we get du is equal to 2x dx. Now what I'm going to do instead is I want to match an x dx from the original integral. So instead what I'm going to do is divide both sides by 2, and now I have something that I can swap out for the x dx. Well, the x dx is equal to 1/2 du, and recall that x plus 1 is equal to u. Now when I rewrite that, the 1/2 is a constant, so it's going to come all the way out, and I get 1/2 integral u to the 5th du. And I go ahead and integrate that. That would, 1/2 u to the 4th du. And when I integrate that, I'm going to get 1/2 times u to the 5th over 5 plus c. And when I simplify my constants, my coefficients, and I replace u with x squared plus 1, I do in fact get 1/10 x squared plus 1 to the 5th plus c. And so we see that the second integral is really 1/2 of the first, or the first is twice the second. In the second example, I'm going to compare another problem that we did in the previous video with a slightly different version of it. And there we had integral of 3x squared times the square root of x cubed plus 1 dx. And here again I have integral of x squared times the square root of x cubed plus 1 dx. So by looking at the constants, you can see that the first integral is really 3 times the second integral, or the second integral is 1/3 of the first integral. So we're going to demonstrate that using U substitution. And I'm going to put the answer from the first one, which was 2/3 x cubed plus 1 to the 3/2 plus c. And so if the second one is 1/3 of that, then I think we're going to get 2/9 x cubed plus 1 quantity to the 3/2 plus c. So let's see if we actually get that doing U substitution. So once again, our inside function is x cubed plus 1, and its derivative is 3x squared, and we're not going to match that exactly, but we do have a constant multiple of it. And so u is x cubed plus 1, du then is 3x squared dx. And once again, you note we don't have 3x squared dx in the original integral. We only have x squared dx. So I'm going to divide both sides by 3. And then I can swap out x squared dx and replace it with 1/3 du. And of course x cubed plus 1 is u. When I simplify, the 1/3 comes out because it's a constant multiple. I get 1/3 integral of u to the 1/2 du. And that is 1/3 times 2/3 u to the 3/2 plus c. When I swap out the u, I get, and simplify my coefficients, I get 2/9 x cubed plus 1 quantity to the 3/2 power plus c. And that's my final answer. And you can see that it is 1/3